In this session, we're going to talk about significant figures and some unit, conversion questions. Now, what are some of the basics before we start, solving these questions? What are significant figures themselves? So one thing that you should understand is that significant figures are those digits that you record in a measurement. Now, when you're recording a digit, let me say you found like 20. The more you're going to the right, the more your digits are becoming uncertain. You are not sure if they are significant. Okay? So that is very, very important for us to understand. And the number of these significant figures in a measurement would depend on the device that you are using for measuring that. For example, if you're measuring a length, maybe you're using a certain ruler, one might just give you, 20 meters exactly. Probably another one, which is maybe even more accurate, might give you something like 2.1. Another one might go as far as 2.1934. The more you are going in the right direction, the more you are becoming more and more uncertain. So that's why we have to understand significant figures. Now, there are different rules that we follow when we're talking about significant figures. Let's start with the zeros. So the zeros are what usually plays a major role in significant figures. So one thing that we should understand is that all non-zero digits, they are significant. All of them are significant. What about the other kind of zeros that you are supposed to understand? We've got what we call trailing zeros. Now, what about trailing zeros? Trailing zeros are zeros to the right of a non-zero digit. These ones are only significant if followed by a decimal point. Okay? If I have a number 2, maybe 5, like that, all the zeros that will come this side are what we are calling trailing zeros. But now, these zeros, they'll only be significant if there is a point. Let me say I put 25.00. This would mean that these zeros are significant. So this one will have 4 significant figures like that. Now, what other thing are you supposed to understand? What if you have 100.0 like that? How many significant figures are you going to have? You're going to have 3 significant figures. Now, what about if I have just 100? Now, in this case, we are not really sure if the 2 zeros are significant or not. Therefore, this one is just going to have 1 significant figure. Okay? So, for trailing zeros, they are only significant if they are followed by a decimal point. Then, on the other hand, if you've got a bar on a zero, let me say 26000. Let's say you have a bar on one of the zeros. Let's say your bar is here. Now, this bar means that's where you are ending. So, therefore, this one will have 3 significant figures like that. So, if there is a bar, it will show that that's where your zeros, even this zero is also significant. So, that is important for us to understand on trailing zeros. Then, what about if your zeros are in front of a number? Or let me say of a non-zero digit. Leading zeros. So what about leading zeros? These zeros come before the numbers. Okay, so if I've got, let me say 0, 0, 0, 2 now, or just 0, 3, all these numbers, the two zeros are not significant. Why aren't they significant? Because they are just acting as place holders. So leading zeros are not significant. Another example is, even if I put a point anywhere, they'll just act as placeholders. This one will still have one significant figure. This one will still also have one significant figure. Now, let me give another example. Let's say you have a 0.00046. So what would be the number of significant figures in this case? All these trailing zeros are just acting as placeholders. So in this case, we only have two significant figures, the 6, the 4, and the 6. They are the only figures that are significant. They are only digits that are significant in this case. Now, what if we talk about other type of zeros? They are what we call captive zeros. Others might call them internal zeros. Now, just the name itself suggests these zeros will be in between, non-zero digits. And all zeros in between non-zero digits are significant. If I've got 10101, this will have 5 significant figures. Why? Because all these zeros, even in between, they are significant. So that is very important for us to understand. Another example that I can write, if I've got 203, this will have 3 significant figures. So this is very, very important for us to understand. So these are some of the rules that we are supposed to understand as far as this topic is concerned. Okay, now that we've talked about these significant figures, for big numbers you're going to use significant figures. Okay, you're going to use scientific notation. Actually, that's what I meant. Okay, now that we've introduced this, let's solve some questions. How many significant figures are in each of the following? Okay, so we have the first one. How many significant figures are in the first one? Now you're able to see that this has 4 digits, and we have a captive zero, or we have an internal zero. So this is going to have 4 significant figures. Now you can pause this video and try out these questions to familiarize yourself as we are solving. Now we come to the second one. B is 0.00289. How many significant figures is it going to have? Now you're able to see that it has 3 zeros, which are just acting as placeholders. So these ones are, your leading zeros are not significant. Okay, so in this case, this one will have 3 significant figures like that. We come to the third one. We have 1030. Now we have a terminal zero, or we have a trailing zero, a zero at the end of a number. But now there is no point. We say trailing zeros are only significant when there is a point, meaning we are certain about that zero, it being significant. So in this case, this one, how many significant figures is it going to have? It will also have 3 significant figures. Now let's come to the third one. We've got 7.0040 times 10 to the power negative 3. So how many significant figures is it going to have? Is this going to have? So let's count. We've got 1, 0, 1, 2, 3, 4, 5. Okay, so this will be 5. Why is it 5? Because there is a point, and all the zeros after a point, they are significant. So unlike this one where there is no point, but this one there is a point. Because of this point, the 0 at the end is also significant. So in this case, this is going to be how many significant figures? 5 significant figures. This expression is what we are calling scientific notation, okay, for bigger numbers or smaller numbers like that. Now, what about E? We've got 102.00. We said the trailing zeros are only significant when there is a point. In this case, there is a point, so even those 2 zeros are significant. So in this case, how many significant figures are we going to have? We're also going to have 5 significant figures. Now let's come to the to F. F, we've got 0.000980. Okay, so how many significant figures are we going to have? We've said your leading zeros that come before non-zero digits, they are just acting as placeholders, so they are not significant. So in this case, because at least we have a point, this point would mean that the 0 at the end will be significant as well. So this one will have 3 significant figures. Now let's come to the last one, G. We've got 9.80. How many significant figures are we going to have? We have a 0, a 0 at the end, a terminal 0, a trailing 0, and there's a point. So we are going to count that as also significant. So in this case, we're going to have 3 significant figures. So that's all that we can talk about on this one. Very, very important. Now let's go to the second question. We are taught to perform the following calculation to the correct number of significant figures. Okay, so we have to perform calculations here. So we'll be adding, we'll be subtracting. So we are adding, we are subtracting, we are multiplying, we are dividing. So all the mathematical operations are going to be considered. So what are we going to do? So for these ones, what are you supposed to understand on, when you're multiplying and adding? So let's start with when you're adding, addition stroke subtraction. Multiplication stroke division. So how do you deal with these two, and how do you deal with these other two? So when you're adding, two numbers or more numbers, when you're subtracting 2 numbers or more numbers, the rule is still the same. Round to the number of decimal places as the least precise value. Okay, you are getting the least precise value. So what do we mean about the least precise value? Allow me to just write it down here. So which one is least precise between the two? If I write 12.01, then another one has got 12.01989, let me say 7. Now this first one is precise, but it is not as precise as this one. What is the difference? this instrument is just only able to measure 2 decimal places in front of the decimal point. But on the other side, this one, it can go as far as measuring about 6 decimal places. So this one is more precise. So when you are adding or subtracting, you are getting, your answer should be with for the significant figures will be for that one with the least precise value. So that's what we're talking about. Then for multiplication, what is the rule? So for multiplication, you round to the same number of significant figures as the least precise value. So it is the same thing. It's just that in the first one we're talking about decimal places. Decimal places. Now in the second one we're talking about significant figures. So for the second one, you're only looking at how many significant figures the first one has and how many significant the second one has. We can use the same analogy that we had, 12.01 and let's say 12.01989 or 7, like that. So now, of these two, which one has more significant figures? So this one has a lot of significant figures, so we're not going to consider it. On the other hand, we're going to get this one with the least amount of significant figures. So our answer we're going to round it off to, in this case, to 4 significant figures, because it has 4 significant figures. So that's what we are doing. Okay, now that we've talked about these rules, let's solve these questions that we have. So 12.0550 plus 9.05. Okay, so I'm going to use a calculator for these ones. So I'm getting 21.11. Okay, 2 significant figures, because I'm only concentrating on the one with the least significant number of figures. Okay, now let's solve this one. 5.98. Let me just use a calculator. So we've got 257.9.2 minus 19.789. So I'm finding 237.411. Now if this is what I'm finding, what would be the final answer? I have to consider the one with the least amount of decimal places, because this is addition and subtraction. Which one of the two has the least decimal places? So this one only has 1 decimal place at the end, the other one has 3 decimal places at the end. So it means my answer, I'm going to round it off to 1 decimal place. Therefore my final answer will be, I'm going to have 237 point. Since this is a 4, when the number that follows it, when it is greater than 5, or when it's 5 or greater than 5, I'm supposed to round off by adding a number to the number we're converting to. But the opposite is also true. If the number is less, it means you're not supposed to add. In this case, I'm going just to have a 4. So 0.4. So this will be our final answer. Now let's solve the third one. Now for the third one, we've got 6.21 times 10 to the power 6.21 so we're saying 6.21 times 10 to the power 3. You close the bracket, multiplied by 0.150. Okay, this is giving me 931.5. So if it is giving me that, now how many significant figures am I going to consider? Okay, so because we are multiplying these two expressions, we are considering the number of significant figures. So how many significant figures are we going to consider? So look at this expression. How many significant figures does it have? It has 3 significant figures. So this has got 3. How many significant figures does it have? This one, it also has 3. How many significant does this one have? It also has 3. Therefore, my answer should also have 3 significant figures. So in this case, I'm going to round off to the nearest number. So in this case, I'm going to have 932. Why 2? Because there's a 5 in front of the one that we're converting to. Okay, now let's come to the third one. So we have 0.0577 divided by 0.753. Okay, so I'm getting 0.076626826. So what will be my final answer? So because we are dividing, I'm also going to consider the number of significant figures. Okay, the number of significant figures. So how many significant figures does this one have? You're able to see that it has 3 significant figures. How many significant figures does it one have? It also has 3 significant figures. Therefore, our answer should have 3 significant figures. So which one are significant? We said the first zeros. These ones are just acting as placeholders. So we're going to get these 3. So we have 766. We're not changing the other 6 because we have a 2 that is following. That's 6, and it is less than 5. Now let's solve the third one, or let's solve E. We've got 27.5 times 1.82. The answer divided by 100.04. So I'm getting 0.50029,988. So what will be my final answer? Again, I have to consider the number of zeros and the number of... In this case, since we are multiplying and we are dividing, we're going to consider the number of significant figures. How many significant figures does each one have? Okay, so this one has got 3 significant figures. This one has got 2 significant figures. This one has got 3 significant figures. This one has got 3. Is it 2? 4? 4 actually. 4 significant figures. So our answer, how many significant figures is it going to have? So in this case, we are getting the one with the least amount of significant figures. But in this case, I'm also going to consider the one with the least, amount of decimal places, because our answer in this case, what is going to be our answer? I'm going to have 0.5. Since we're considering one with the list 0, let's say 0, like that. So two significant figures. Actually, we're going to go for the one that has 2. So this is where we're going to, that will show the number of significant figures this have, because we said, we're saying, yeah. So we are saying when the zeros at the end, when there's a decimal point, they're also significant. So in this case, it will have 2. So that is how we're going to solve that one. What about this other one? We've got 2. So you just put them the way they are. Don't just make a mistake when you're multiplying and dividing these expressions. That is 10 to the power 2.29. So you open your brackets first. 2.29, 0 times 10, that is to the power 6. You close the bracket, you put your division sign, you open the bracket. When you open the bracket, we've got 6.7 times 10, that is 10 to the power 4. You close the bracket. What do you get? So I'm getting 34.1791048. Now what am I going to have as my final answer? So again, I'm going to consider the number of significant figures. Okay, so how many significant figures does this one have? So this is 6.7 times 10 to the power 4. So this one has got 2 significant figures. How many significant figures does this one have? This has got 4 significant figures. So it means our answer is going to have 2 significant figures only. So in this case, our answer will just be 34. Okay, now let's solve the last one. For the last one, I'm just going to put it the way it is. I open the brackets. I'm going to have 28.7 multiplied by, I've got 10 to the power 5. I close. I divide by, then that is 48.533. then I close. So I've found the answer. Then I add 144.99. So the answer that I'm finding is I'm finding 59,280.01153. So when I round off this one in terms of significant figures, so here we've got multiplication, we've got addition, but how many significant figures and the number of decimal places are we going to consider? Okay, so how many significant figures does this one have? It has 5, that is 5 significant figures, but it's got how many decimal places? It's got 3 decimal places. We come to the other one. How many decimal places does this one have? 3. How many decimal places does this one have? 1. Okay, then in terms of significant figures, how many significant figures does the first one have? It has 3 significant figures. This one has got how many significant figures? 5 as well. So which one are we going to consider? Okay, So we're getting one with the least amount of significant figures. So in this case, we're going to go for 3 significant figures and 1 decimal place, because these are the least. Okay, so meaning our answer is going to have 3 significant figures. Okay, so in this case, we're going to have 5, 9, 2. Okay, 5, 9, 2. If you want, you can put the zeros like that. So that is our answer. I don't know if I did the calculations correctly, but if that is what we are getting, it means we need to round off the 2. Therefore, I'm going to have 5, 3. Then I can put zeros here. It means the first 3 are significant. Okay, so that's how we are going to go about it. Now let's solve these questions on rounding each of the following numbers to 3 significant figures. So how are we going to round this one? So we've already talked about how we round off. So to 3 significant figures, what is this one going to be? These are the 3. Then the one that follows is 7. Because it's greater than 5, we're going to add a 1 to the preceding number. So that is 4, 3, 4. To 2, we are going to add a 1. That is going to be 3. That is 3 significant figures. We come to the second one. We've got 9845.8. We're also converting to 3 significant figures. So what are we going to have? I'm going to get the first 3, 980. Then on the 4, am I going to add the 1 or not? So I'm going to add the 1 because the number that follows is a 5. So I'm going to have a 980. To the 4, I'm going to add the 1. That will be a 5. So that will be significant figures. When I come to this number C, what am I going to have? So we said all these zeros in front, they're just acting as placeholders. So I'm going to get the first 3 and I consider the last one. So this is 3 and it's followed by 8. 8 is greater than 5. So I'm going to 3 I'm going to add a 1. So I'm going to have 0.0000. Hope I've not missed a 0. I'm going to have 4, 5. Instead of having 3, I'm going to have 4 because the number that is following it is greater than 5. So that is it. Then when we come to D, we have 2.4555, 555 and like that and others. So what are we going to have? So we're also going to consider significant figures. We're going to get 3. Those are the 3, 2.45. But the number that follows is a 5. So what are we going to have? I'm going to have a 2.4. Instead of having another 5, I'm going to have a 6 because the number that follows is a 5 or greater than 5. So that will be that one. Then when we come to E, 76.89. What is it going to be? I'm going to have 76. To 8, I'm going to add a 1. So I'm going to have 76.9 because the 9 at the end is greater than 5. Then we come to the last one on this one. We've got 56. Now we've got a 9. So it means we're considering these 3. Now we have a 9 here. So it's greater than 5. So we're going to add a 1 to the other 9. When we add the 1 to the other 9, we're going to have a 10. And that we carry that 1 to the other one. So I'm going to have 57.0. This would be, 3 significant figures. So that's how we are going to solve, those ones. Now lastly, let's do some unity conversions. So sometimes we're given 1 unit and you're taught to convert probably to, let me say, the fundamental units, or let me say you'll be asked to change just from 1 unit to another, depending on what you're trying to find out, okay, or you're trying to compare. So complete the following conversions showing all work. So the first question is how many milligrams how many milligrams in 45.9 grams. Okay, now you know that the conversion factor for A, you know that 1 gram is thus equals to 1000 milligram. So that is the conversion factor. So now that we have got the conversion factor, you are going to have 45.9 grams. This is going to multiply by, we're saying 1 gram is equals to 1000 milligram. Okay, how many milligrams? Okay, so the gram and the gram can divide, therefore I'm just multiplying what is on top, and when I multiply by 1000, so it means the 0 is going to move 3 times. 1, 2, 3, excuse me on that one. So we're going to have 45900 milligrams. So that would be our answer here, 45900 milligrams. So that's how you're going to solve the first one. So what is the key? Know your conversion factors. Not very complicated. You can check our videos on prefixes, on units and measurements, in chemistry, even in physics. Now we're told to convert 0. So we're converting B. We're converting 0.099. Okay, let me just write it nicely so that I don't 0.998987 actually mils to liters, or milliliters to liters. So what is the conversion factor? You know that 1 liter is just equals to 1000 milliliters. Okay, so that's what it means. Or the conversion factor, you know that if I say milliliter, milli itself is just 10 to the power negative 3. Okay, so that's what it means. So that is a conversion factor. So how are we going to solve this one? So what we have that is milliliters multiplied by our conversion factor. So we're saying 1000 milliliters is equals to 1 liter. So always place your measurements in terms of you trying to cancel the 1 to which you are trying to convert to. So what are we going to have? I have the mil and the mil, they are going to divide. Then I've got the 1000. 1000 is dividing in this whole expression. Now when I use a calculator, 0.09987 divided by 1000, I'm getting 9.887 times 10 to the power negative 6. Now what is the unit? Liters. So that is what we have on the second one. We have 9.887 times 10 to the power negative 6 liters. So that's how you're solving this one. Let's solve 3. We've got for C we have 0.35 mils is equal to how many liters? So even this one we're converting to liters, and we said 1 liter is just equals to 1000 milliliters. So what are we going to do? Same thing. So we are saying 1000 milliliter is equivalent to 1 liter. Then what do? We cancel the mil, we cancel the milliliter. So we are dividing 0.35 divided by 1000. And what are we going to have? I'm having 3.5 times 10 to the power negative 4 liters would have converted to liters. So that's what we have for C. Allow me to write my answer here. 3.5 times 10 to the power negative 4 liters. I'm keeping these answers because I want to show you something. So before I go any further, we've written this one in terms of 3 significant figures. Why? Because what we have has got 3 significant figures. We've written this one in terms of how many significant figures does it have? It has 4. Even our answer has to have 4 significant figures. Okay? This one, because we're dividing and multiplying. So this one, 0. That it has 2 significant figures. Even my answer should have 2 significant figures. So that's how I was keeping these answers. Now let's also solve D. D we are converting. So D we are converting 2345.98 meters. We're converting it to what? To centimeters. How many centimeters is in that? Okay. So since we're converting to, you know that 1 meter is equals to 100 centimeters. Okay. Now that we've got this, what are we going to do? We're going to multiply this by the conversion factor. So we put the 1 meter down, divided by the 1000 on top. 100 centimeters divided by 1 meter. Now that we've got this, what do? We cancel what is common. We cancel the 1 meter and the 1 meter. And when we do that, what do we have? It means what we have on top, we are multiplying it by 100. Now if you multiply by 100, you're able to see that the 0 is going to move 2 steps. The point, the point is here. So it's going to move 1, 2. Because we've got 2 zeros, so that's what will be. That's what we are going to do. So I'm going to have 2, 3, 4, 5, 9, 8. To which unit are we converting? We've remained with a centimeter there. I'm going to write my centimeter. So this will be our answer for D. So D, we are saying we found 2, 3, 4, 5, 9, 8 centimeters. Now when we solve E, now E, how many degrees Celsius are in 45.9 Kelvin? Okay, so now we're converting these kelvins to degrees Celsius. And what is the conversion unit? You have to know that if I've got a temperature in degrees Celsius, the way I'm going to find it in terms of Kelvin, you're going to get your Kelvin temperature minus 273.15. This is a conversion factor. I don't want you to forget this conversion factor. So now that we've got this, what are we going to do? We're just going to replace indefinitely to get our degree Celsius. Now the opposite is true if they told you to convert to the other one. Okay, so if you know this one, you can manipulate it the way you want it to display. So the temperature in Kelvin we've been given, it is 45.9. So we're going to write our 45.9 minus 273.15. What do I have? So I'm saying 45.9 minus 273.15. So I'm getting negative 227.25 degrees Celsius. So this will be our answer for E. So E, we are saying negative 227.25 degrees Celsius. So that is our E. Okay, allow me to rub this. We've got F there. Convert 475 kelvins to degrees Celsius. So it is not very much different from the previous one, so we're just going to use the same formula. Okay, so we've been given a temperature in Kelvin. We are saying we've been given 475 kelvins minus 273.15. What do I have? 4.75 minus 273.15. I'm getting 201.85. Now this is in degrees Celsius. So that's what we have as our F, 201.85 degrees Celsius. Now that we've got this, let's solve the last question. Now the last question, we're saying how much Kelvin is in negative 255 or negative 255 degrees Celsius. So now when you're converting, so this one will be a bit different. When you're converting to Kelvin, okay, so your temperature in Kelvin will be equals to the temperature that you have in degrees Celsius. You're going to add a 273.15. So this is a conversion, factor. So now that we got this, what do you do? Let's replace what we have. So we have a temperature in degrees Celsius, which is negative 255 degrees Celsius, plus we've got, now we're adding 273.15. Now when I add negative 255 plus 273.15, I'm getting 18.15. Now we're converting to what? To Kelvin. So this will be our final answer. For the last one, we're saying 18.15 Kelvin. So pretty much we've solved and we've explained, actually we've explained significant figures, we've explained rounding off, we've also converted some units. So basically this is the basic introduction to chemistry. Okay, then in another session, that's what we're going to talk about the more concept, and you build up from there. So thank you, don't forget to subscribe, and see you in other sessions.